and it's our very special pleasure to welcome with us Nicolas Bosse. He's a Chief Energy Transition Officer at BrainBox AI and will deliver his keynote on demand management from autonomous commercial buildings for an affordable and resilient energy transition. Nicolas, can you hear us?
Yes, I can.
Wonderful.
Can you hear me?
Yes, we can hear you. And I think it's very early in the day in Canada. I don't know if you followed the conference so far.
Not yet. So it's 8:30 in the morning. So yeah, it's not that early.
Thank you for being with us. I have already received your slides here. And once again, this is live. Have a listen to the keynote of Nicolas and ask your questions, which we will answer in the Q&A session that follows right after his presentation. The floor is yours, Nicolas.
Great, thanks. So thanks for the invitation. It's a real pleasure to participate here and to speak to you about what BrainBox is doing. So BrainBox is using and applying the most advanced AI to manage HVAC system in commercial buildings, and our goal is to make them energy efficient and grid interactive. So today I'll discuss energy efficiency and demand side management, and these are key elements for a successful energy transition. And further, the unfortunate recent events are shedding some lights on the challenges posed by the electrification of the economies and the need to maximize existing infrastructures. And these are two of the key elements at the heart of BrainBox AI's mission. So BrainBox was founded in 2017 and commercially launched in 2019. And we currently employ up to 150 highly skilled people, mainly located here in Canada, Montreal, Canada. So since our commercial launch in May 2019, we have developed up to 275 relationships with buildings, representing about 1 million square feet of buildings span across 18 countries. And this speaks loud about the scalability of our CapEx-free SaaS business model and our go-to-market strategy. But behind this success is the fact that the asset managers are eagerly looking for cost-effective solutions to reduce their Scope 1 and 2 emission. So to achieve our collective net zero objectives, we need to rapidly scale innovation in the built and the energy sectors. This is what BrainBox is doing with two distinctive solutions. One geared towards reducing emissions at the building level, and the other one is to have these energy efficient buildings interact with the electrical grid to provide demand flexibility. So our technology is analogous to the autonomous car. So our core technology extracts granular operational information from the building management system, append to that data, external data, and provide energy efficiency benefits by managing every single element of the HVAC system. This in order to drive energy and GHG savings. So managing buildings are quite complex and becoming more and more complex. So in order to deal with that complexity, we use data to satisfy the needs of the different stakeholders linked to commercial buildings. First, the asset owners. Asset owners want to increase the value of their assets. So our solutions provide reduction into OPEX and CAPEX, which have a direct impact on the net operating income of the building. More and more you see ESG commitments and net zero commitments. So you need to satisfy the needs of the sustainable officer. So our solution optimize and move energy consumption when the carbon intensity of the grid is the lowest, helping reduce Scope 1 and 2 emissions. And finally, the operating and technical manager, these guys needs to maintain set points and tenant comfort while avoiding equipment failure and extend their useful life. So against this backdrop, buildings have to overcome several challenges to become energy efficient. As we know, buildings are large consumers of energy and therefore large contributor of CO2 emissions. And large swaths of energy consumed by building is wasted. So finally, current energy efficiency solutions require large amount of capital, highly skilled workforce, and takes a lot of time to implement. So our solutions offer cutting-edge technology, AI technology, software as a service that enhance the existing HVAC equipment and transform those equipments into a predictive and self-adapting HVAC system using AI and cloud computing. So in sum, our technology is continuously acquiring information to predict the future state of the building and optimize users' experience. With embedded AI loops, one that automatically drive the build, which is part of a larger one that ensures the solutions provided are optimal compared to alternatives and feeding the actions to be taken. The outcome and impact of those actions serves to reinforce the AI to create a virtual learning circle. So following the same logic, our second product is leveraging the same data from multiple buildings to meet challenges posed by the electrical grid operator. Those are reduce the consumption, shave peaks, and manage local congestion. One of the key features of our solution is understanding the future and how we use this information to drive significant private and societal benefits. So why is this important and why does it matter? So 3 weeks ago, only a few people would have understood or foreseen the value and benefits of high demand side management penetration. Now it's on everybody's mind. Everybody's asking the same question: what can be done to curb our reliance on natural gas? With the increased decentralization and intermittency of the electrical grid, more flexible non-natural gas resources are needed to ensure a reliable and resilient grid. Historically, that flexibility was provided by natural gas resources. As the pressure to retire and reduce reliance on natural gas increases, operator needs to find alternative flexibility. Demand-side management becomes a significant opportunity to provide such flexibility. So as alluded before, our technologies are able to address two of the most significant challenges posed by the climate change crisis. Our community AI solution makes building grid-enabled and efficiently use energy when the emissions are the lowest. It reduces the needs to increase emitting generation infrastructure, maximize usage of existing renewables, and increase the utilization of large transmission and distribution infrastructure, therefore limiting cost pressure on consumers and its negative impact on the economic growth. So by using the thermal characteristics of the building, we transform it into a thermal battery, providing energy products to the electrical grid. We call these buildings grid interactive efficient buildings. Now, imagine that we take several buildings in the same vicinity and combine them together and optimize them to solve the grid challenges. We create large virtual power plants available to provide local flexibility to balance the new decentralized electrical grid. Creating size and scope on a local basis is of the utmost importance in dealing with the electrification of the economy or the immediate challenges posed by the reduced availability of natural gas. Indeed, switching from gas to electricity is easier said than done. The electrical grid has not been built or designed to manage such an increase in power usage. The lines are becoming congested. Local load management will become increasingly important, otherwise the infrastructure costs to electrify the economies will be prohibitive. So as we round up, demand-side management is not a novel idea. it's been around and used to manage large industrial loads for a long time. And more recently, the surge of low-cost IoTs has prompted the increase of residential demand-side management. But managing commercial load is a blind spot in the sector because of its complexity. Thanks to AI, this complexity is becoming an asset. So commercial load is perfectly suited for the challenge posed by the energy transition as well as the electrification of the economies. It has a good mix of size and location, key characteristics to meet the challenges before us. So thanks, and I'll be more than happy to answer any questions you may have on our solutions. Thank you.
All right, and here we are back again. And we received a couple of questions, namely the first one being, from your point of view, what are the two main challenges of implementing AI solutions in the energy industry? What kind of obstacles have to be overcome?
So energy, I mean, both energy and commercial buildings are two sectors that are quite conservative. And it's very difficult or challenging to come up with novel solutions and so on. So frankly, most of the people recognize the value of demand-side management at large scales and the need to find ways and alternative ways to provide grid flexibility in order to manage the new intermittency and this decentralization of the economies of the electrical grid. But on a single, like on a piece-by-piece basis, it's very difficult to access the data or to penetrate a market. So I would say the conservatism is probably the single largest constraint into large-scale deployments of technologies such as the ones we're advancing here.
Thank you, Nicolas. And BrainBox AI, your company, has actually grown very fast and tackled a couple of different markets. Which has been the most difficult market to tackle so far, to get into?
So from an energy efficiency standpoint, our market is actually the asset owner. So it's most of the time they are quite sensitive on managing their costs, energy costs, especially the HVAC costs, mainly represent about 50% of the overall invoices or line items cost into a building. So providing a solution that is readily available and capex free is quite appealing for them. So since we've launched in May 2019, most of the market has kind of switched from energy efficiency and cost savings to GHG savings. Most of the large asset owners, they have these commitments, ESG commitments, as well as net zero commitments, and they need to find ways to reduce in a cost-effective manner their emission. Solutions like ours is really compelling to achieve those objectives. Mm-hmm. And from an energy market perspective, we're kind of at the mercy of the regulatory framework that governs who has access to the market and so on. We see a lot of actions in the UK, for example, which has been leading this sector, the demand side management and flexibility procurement. They are quite advanced, and we see a large momentum from the EU countries to follow suit and adapt the regulatory framework that has been implemented in the UK. So these are for us, these are like growing markets, And we're putting a lot of attention into those markets to first enable more buildings and then provide energy flexibility into the energy markets.
Thanks a lot. And attached to that answer, do you plan to expand to Europe? What about your European expansion plans? Can you share some insights?
Yeah, so as mentioned, so Europe is a key market for us and a key growth market. So far, we're implemented obviously here in Canada, and naturally we've expanded to the US. And oddly enough, our third largest market is Australia, and we've expanded in Australia during the pandemic. So this kind of speaks a lot about the scalability of our technology. Just as an anecdote, no one from BrainBox has ever set foot in Australia. Everything has been done remotely. As to your question, Europe is really a key target for us. UK and the EU in general. From both the energy, the energy prices are really driving decisions in the EU, and so we're able to provide solutions both on reducing the overall cost of the energy, providing GHG benefits, as well as enable the buildings to contribute to the energy transition. So I think the European market is a key growth market for us.
Thanks for that answer. And also interesting that you are going that strong in Australia. We already heard some couple of inputs from Australia directly from your PwC colleague, Matt Cooperholz, but time zone wise, it's probably hard for you two to meet at the same conference. No, wonderful. Do we have more questions? So far, not. But I can see that some of your colleagues from BrainBox AI are actually joining the B2B meetings that will start at 2 p.m. Central European time, which is now. And I can only invite our audience, our participants, to reach out to them on the B2B matchmaking platform if they want to know more and discuss in more details possible collaborations, etc. Nicolas, thank you so much for joining us today, and we wish you a very nice day in Canada here from sunny Vienna, and hope to meet each other soon.
Great, thank you, and thanks for the invitation.